So, if I'm looking at 54, what is the largest number on this list that can go divide equally into 54? 9, right? And 9 times what number makes 54? 6. Now, 9 is a perfect square. So 9 can come out of the radical. So when this comes out of the radical, right, what is the square root of 9? 3. So 3 comes out, the 6 stays behind. Is that the way you've done it before? Somewhat? Let's look at 32. What's the largest perfect square that goes into 32 equally? Just take a calculator and start dividing and see. 16 is the largest perfect square, right? 16 times what number is 32? 2. What's the square root of 16? So 4 can come out, and what stays underneath? The 2. Okay, so now I'm looking at square root of 20. Square root of 20 is the square root of 4 times 5. What is the square root of 4? 2. So the 2 comes out, square root of 5 stays in. Okay, 24. What's the biggest perfect square that goes into 24? 4. 4 times what number? 6. What's the perfect square of 4? 2. So that's 2 square root 6. Right? Remember? Is it all coming back? And we're going to do one more. What's the largest perfect square that was on that list? That goes into 125. 25. And there are 5 quarters in $1.25. So that's times 5. Square root of 25 is 5. And then the square root of 5 is here. Dun, dun, dun. Right? Okay. So today we're going to start off with Pythagorean Theorem. Hopefully we'll get to similarity. That's the plan. Has anybody here ever heard of Pythagorean Theorem before? Okay. So in the United States, Pythagorean Theorem is seen on like all standardized tests. I'm just saving this so I don't lose my. You see it all the time. So I'm going to leave this and I'm going to pass out today's. Oh, I don't do that. No. Okay. Oh, ow. So I'm going to go ahead and go to Google Classroom. Nope, that's my email. That's not Google Classroom. This is my Google Classroom. Okay, do. And so today, six Pythagorean theorem. Da, da, da. There we go. Okay. So Pythagorean theorem only works on right triangles. Okay. In the United States, it's typically introduced at about 6th, 7th grade. And then, of course, it gets more and more complicated as you go higher and higher with math. Okay. Um, so, students will apply the Pythagorean theorem to find missing sides of lengths, including from real world applications. Real world applications mean everybody's favorite word problems. Students will be successful 80% of the time. Now, the reason why we have word problems is, do you remember I just said a little bit ago that Pythagorean theorem itself is actually a 6th, 7th grade standard. It is actually not a high school standard. What makes it a high school standard is when I start giving you word problems and when we use the converse of the Pythagorean theorem to see what type of triangles we have. Those are actually high school level material. Okay? But because some of you may not have seen the Pythagorean theorem, or you may have seen it, but it's been a long time, I do go over the basics. So how the Pythagorean theorem works is you have a squared plus b squared equals c squared, where a and b are the length. I have a copy of the notes right on the edge right there. Where a and b are the legs. What makes the legs is the right angle. See here how it makes a right angle? It makes a corner. A and B are the legs. The hypotenuse, and let's try saying that together because it's a hard word to say. Hypotenuse is always the longest side and it's opposite the 90-degree angle. Okay? And C is always on the side by itself. So whenever you're doing these type of problems, you always want to identify your hypotenuse first. And there's a copy of the notes on this corner before you get comfortable. Thank you, Myra. Okay, so when you are doing this, you're going to label A and B and then you label C. Always label C first because it doesn't matter which one's A or B because we are just adding. Because 2 plus 3 is the same thing as 3 plus 2. Yes. It's because of the community property of addition. Because no matter which order you add things, you get the same answer. But C has to be correctly marked, or you'll get the problem wrong. So, like here, if I have 3 and 4, what I will do is I will square 3 and I will square 4. So 3 times 3 is 9. 4 times 4 is 16. I add them together. I get 25. And then I take the square root. Does that make sense? Okay. Don't forget to do the square root. I've been doing this a long time and seen many tests throughout my lifetime of teaching math. And many times when people make mistakes on these, they forget to take the square root at the end. But it would not make sense after the triangle inequality theorem that we worked on with measuring all those little sticks that this would be 3, this would be 4. This can't be 25, right? It wouldn't make sense, but it could be 5. Okay, so let's try doing some of these. It's saying to go ahead and round to the nearest tenth. You have to be careful. Sometimes worksheets will have you just round it. Sometimes you have to give the exact answer. When it asks for the exact answer, That's when you reduce the radicals like we did in the do now. So over here, does a, I'm going to look, oh, I'm not in Cami, I'm sorry. Oh, Cami. I can't write on it when I'm just in Google Slides. It's not great. I mean, Google Slides is nice because it's free for the school, but PowerPoint is so much nicer. Okay, talked about all that. Okay, so let me erase this answer so we don't see it, and we'll work on these. We'll work on two of these together, and then I'll have you do one by yourself. Okay, so in this case, we we are given the two legs, right? And so I always mark my C first. C is always opposite the 90. So this is C. Does it matter which one I call A or B? No. So I'll just put A here, B here. And according to the theorem, A squared plus B squared is equal to C squared. So 2 squared plus 5 squared is equal to C squared. What's 2 times 2? What's 5 times 5? 25 is equal to C squared. And then we have to do the square root of 29 to get C. So it should be about 5 point something. Remember on these calculators to get the square root, you'll have to hit the second button at the top and then go to where it says x squared to get a square root sign. Make sure you have a calculator there on my wall. Now is a good time to grab a calculator if you don't have one. And I would get about 5.4, right? Does everybody have a calculator? Oh, go ahead and grab one off the wall. Wait. 5 point, it said to the nearest tenth. This is 3. What's the number behind it? Is an 8. So that bumps this 3 up to a 4. So it would either, when you're rounding, it's either going to be 5.3 or 5.4. You look at the number behind the number you're rounding. Oh, by the way, because my husband and I have such interesting conversations, I just the other day I was verifying how far he has to round to. And you know, he said he had an interesting job thing he did the other day where he was working for a medical device, doing some engineering for a medical device. And he had to get within 1/10 of the diameter of a hair. Think about that for a second. Your hair is like a cylinder. 1/10 of the diameter of a hair is how accurate he had to be. Isn't that interesting? I thought it was interesting. Okay, so over here, what would I do? This would be C. And it doesn't matter which one I call A or which one I call B. I tend to call the smaller one A for some reason and the other one B. That's just the way I do it, but you can do it either way. So 9 plus, what is 14 squared? 196? Yeah. So then that would be 205 equals C squared. You have to take the square root of 205. So second square root 205, which is 14 point, what am I going to say? 3. 14.3. Okay, now I want everybody to do this next one, and I will walk around and check to see if you're So everybody should have had 21.4. And when I walked around, most people had it, right? Any questions on this? But not always are you given the two legs. Sometimes you're given a hypotenuse and one leg, right? When that happens, you're on opposite sides of the equal sign, so you end up having to subtract instead of adding the squares. So here I'm given C and I have A, but I'm missing B. So I had to do 8 squared plus B squared equals 10 squared. So 64 plus B squared equals 100. But now I subtract, which gave me 36. And then I have to take the square root. And then this would be a 6. Okay? So let's try some of those where you may have to subtract. Okay, so for this one, again, I would mark my triangle. Right? And this is C. And I would have A and I'd have B. And so I would do A squared plus 6 squared equals 9 squared. A squared plus 36 is equal to 81. I subtract 36 from both sides. What's 81 minus 36? 45. And then I do the square root of both sides. Square root of 45 would be, I'm going to guess in my head, 6 point, I don't know, 8. What is it? It's close. That's how I keep myself entertained while teaching the same thing over and over again. Yeah, that's called interpolation, what I just did. 6.7. So this would be done the same way, right? C is 4, and then I have A and B. So I have A squared plus B squared equals C squared. And so I would do A squared plus 1 squared has to equal 4 squared. So I'm going to write up here because it's hard to see when I write over that blue. 16 is equal to A squared plus 1. So A squared would equal square root of 15. So that would be like 3 point, I don't know, 3.9, 3.8, something like that. What is it? 3.9? Okay, so now you all do the third one. I will walk around in a minute here. If you already have it, I think I know what it is. Off the top of my head. Good job. The triples. It's pretty easy. Yeah. Like I said, these are considered middle school standards. So yes, most of you got 9. What? You know, but like the newspaper is actually written like at a 7th and 8th grade level because most people can't read higher than 7th and 8th grade. If people read the newspaper today. Okay, so basically to summarize, when you're given the 2 legs, you add the squares together and then take the square root, right? But when you're given the hypotenuse, you still square the sides, but you subtract the squares and then take the square roots, right? Make sense? Okay. So now these are mixed. Some I'm giving you, and I'll write where the 90 is since they didn't do it. The corners are usually your 90s. Mm-hmm. Oop, come on, get off of there. I don't want the news. Oh, Jiminy. Why did it do that? There it goes. So go ahead and do these. They're all mixed and see if you can get the right answer. Is on these? Oh, they're not on here? No, we don't see them. Oh, no. Okay, well, we'll skip that then. Sorry. I don't know why they're not on your notes. Okay, we'll go to the word problem set. So most of the time when you see these on standardized tests, it won't tell you to use the Pythagorean theorem. It won't even give you a picture like I'm giving you. It'll give you a scenario. You have to draw the picture and realize that you are going to be using Pythagorean theorem. So like here, Brooke is fishing from a small boat. Her fishing hook is 3 meters below her. So if Brooke is right here, here's Brooke, right? And then this would be 3 meters. And it says a fish is swimming below at the same depth as the hook, 4 meters away. So this would be 4, right? So this is your hypotenuse here. And then 3 and 4 end up being your legs. So this would be your 3 squared, which we did earlier. This would be 9 plus 16 is equal to c squared. 25 is equal to c squared. Square root c is equal to 5. Okay? Any questions on that one? No? Okay. So we have a new terminology here. Try decorating a ballroom ceiling with garland. The width of the rectangular ceiling, so I know it's a rectangle, so I'm going to draw a rectangle, right? So here's a rectangle. The rectangle ceiling is the width of the rectangle is 16 meters, and the diagonal distance from one corner to the opposite corner is 20. How much garland would need for the length of the ceiling? So if I call this width, I could call this length, or I could do vice versa. Diagonal. That's a new term. We'll be using that term quite a bit. But your diagonal is going from vertex to the opposite vertex. That's your diagonal. Who here has bought a TV recently? Has anybody bought a TV recently? No? Okay. So TVs and computer monitors are when you buy them, they only give you one number. They say like a 16-inch TV or a 96-inch TV. What measurement are they talking about for the TV? Diagonal. And the reason why they use that is because it's the longest measurement. So it feels like you're getting a bigger TV than what you're getting, right? Because that's a marketing ploy. So instead of giving you the length and width, they actually give you a diagonal length. And so that's where a lot of this is used in real life. Now, really, really good contractors, when they're trying to figure out if they install the window correctly before they like nail it all in, they have it sitting there, they will check the diagonal and they will use Pythagorean Theorem to know what that diagonal length is supposed to be. If that diagonal length varies, then they know that window wasn't installed correctly and they're going to have to make adjustments because that it's not put in at a right angle. And remember, we talked about how important it is for things to be at right angles. Make sense or doesn't make sense? Okay. So if this width is what? 16 and this is 20 and here's my 90, is what is 20 considered? Is that going to be A, B, or C? That's C. I could call this A and I could call this B, right? So 16 squared plus, I could either say length L squared or B squared. It really doesn't matter because is equal to 20 squared. 16 times 16 is what, 196? Double check me on that one. 16 times 16 is, 14 times 14 is 196. What is 16 times 16? 256. I used to know all these really fast off the top of my head, 220. I used to make my geometry students memorize all the perfect squares up to 400 um, because they were all going to be taking the SATs, and it was really important for them to know that. And what is this 144? And then when I take the square root of this, B would equal 12. So the length would be 12. Okay? We good? Yes. It should be meters. Yeah, it should be meters. There. You should put the units. Especially, we're going to get, when we do area, we do mixed units where we have to do conversions. So, yes, it is important. And if you get to physics, Miss Connie is going to want all your measurements written down. When I taught in traditional school, the maintenance guys were doing something with the flagpole, and I asked them to measure the flagpole, and they looked at me funny. And I go, I do a lot of geometry word problems referencing our flagpole, okay? And they did. They measured it for me. Um, and then they laughed. They thought it was funny. Okay, so running from the top flagpole to a hook in the ground, there is a rope that is 10 meters long. So which one is 10 meters? It's C. It's going to be from the flagpole to the hook in the ground, right? So this would be 10. If the hook is 8 meters from the base of the pole, how tall is the pole? So we're wanting this, and that we could call that B. So it would be 8 squared plus B squared is equal to 10 squared. What's 8 times 8? 64 plus B squared has to equal 100. Um, B squared is going to equal, when I subtract that, what is that when I subtract that? 36. And you take the square root. B is equal to 6. So, and that would be 6 meters. Questions, concerns? Am I going too fast? Do I need to slow it down? Going too fast. I'll slow it down. Do you need me to repeat anything? To slow it down a little bit. Okay, I can do that. Okay, so we're on this next one, right? So, Jake plans to use a ramp to make it easier to move a piano out of the back of his truck. The back of his truck is 83 centimeters tall, and the ramp is 158 centimeters long. What's the horizontal? Horizontal, remember, horizontal lines are from left to right. So horizontal distance from the end of the ramp to the back of the truck. So here's a truck, right? And how far up was the truck? What was the height of the truck to the, yep, this one's the 83. This is your ramp. So that one was what, 153? Is that what it said? And they want to know how far along here is this distance, right? So a squared plus 83 squared has to equal 153. Oh, is it 8? Sorry. 158. Thank you. 158 squared. So a squared plus, now I'm going to use a calculator, 83x squared is equal to a big number, isn't it? 6889. 158 x squared, 24964. 249, right? 64. And then I'm going to subtract 6889 from both sides. A squared is equal to 18075, 18075. And now I'm going to do what to both sides? I need to take the square root. So second square root 18075 would be about what, 134.4 meter? Is it meters or no, centimeters? 134.4 centimeters. So actually, from the picture, kind of should have been longer than what it looks like. But that's just a sketch, right? Okay. So when you're having north, south, east, and west, does everybody remember their compass rose? North, south. I always remember we. It spells we to know my east. I can always remember north and south. When I was growing up, I always mix these around. But then I realized, oh, it spells we. So that's how I remember it. So Santos walks 2 kilometers south. When you get to ICP, you do these to find displacement. Who here needs to take or has taken? You have taken ICP? Am I right or wrong? I'm right. Did you do Pythagorean Theorem? No, and that always made me sad. Now, I have taught ICP, and when I teach ICP, I throw it in because you see it again in geometry. So, Santos is walking 2 kilometers. Oh, I almost did it backwards. Let me redo that. Because I was chit chatting and okay, south. So he's here, Santos is here, and he's going south, and that's 2 kilometers. And then a certain amount of kilometers east. So I do not know how much east he went. He ends up 5 kilometers from where he ended. So this is his ending point, right? This is beginning. This is where he ends. He's 5 kilometers. So when you're talking about directly north going east, we assume 90 degrees right there. So how am I going to set this up? What is 5? Is 5 is C, correct? This is C. Am I going slow enough now? Okay. You start telling me when I go too fast, okay? Okay, so what am I going to have as A? I can mark this as A, and I'm looking for B. So A squared plus B squared equals C squared. 2 squared plus B squared has to equal 5 squared. 4 plus B squared has to equal 25. You subtract 4. B squared has to equal 21. So when we take the square root, what's the square root of 21? What is it? 4.6, and I would need kilometers. Make sense or doesn't make sense? We all good? Okay. Now, this is what we call the converse of the Pythagorean theorem. And notice, where's C this time? At the beginning. And that's just so that when you are looking at your lesson and greater than, it makes more sense. Because greater than, we kind of think of obtuse, because obtuse means larger than 90. And less than means acute. And then we have equal. So what you're doing here is you're determining whether or not it is a right triangle or an acute triangle or an obtuse triangle. So you always use the largest number as C. So this would be my C to check this. This would be my C because that's the largest number, right? And this would be my largest number here. So I'm just checking what is well, let me clear that because we flipped it around. I'm going to put the C first. Sorry. So 30 squared, we are comparing. This box is, because I don't know if it's equal, greater than, or less than yet. I'll be filling this in a minute. What's 24 squared plus 14 squared? So what is 30 squared? 900. This one I have to do a little bit of work. Now my calculators, you could do all this step all at once. I notice I see a lot of people putting 24 squared clear, 14 squared clear. You really don't have to do that with these calculators. You could do it all at once like this. 24 x squared plus 14 x squared equals 772, right? 772. So am I going to use, which sign am I going to use? Greater than, less than, or equal? Greater. This one's bigger. Remember, the open mouth, just like Pac-Man, will always go where you have more dots. So this is going to be greater than. If I look back up here, what type of triangle is it going to be then? Obtuse. Because c squared is greater than a squared plus b squared. The larger side squared is greater than the sum. So this is obtuse. Do we all remember what obtuse means? It means this is not 90 degrees. It means it's probably a little bit bigger than 90 degrees. Like maybe 95 degrees or 98 degrees or 100. Well, it can't be an inch. It'd be a couple degrees. Yeah. And when we go to trigonometry, we could actually figure out what those angle measures are if you learn law of sines and law of cosines. But we get into some trig in here. Yeah, we go outside and measure the flagpole. We go outside, measure the height of the building. It's a lot of fun. Um, Set up a trig. Yeah. Okay, so right here, here's C. And so C is what? 34. So 34.2 squared. I'm comparing it to 24 squared plus 27.5 squared. I use my calculator. I wish this calculator would recognize my pen, but it doesn't. That's why I have to switch to the mouse. 1169, 1169.64. 24 squared plus 27.5 squared. 1332.25. 1332.25. So this is what? Less than, so it's acute. It's a cute triangle. So go ahead and try number 3 and tell me what you get. Was that helpful at all, Cindrea? The tea? It is really. I always keep that around. I think that's my last one. Get right? Yeah, it should be right. So they should end up equaling. Did you get it equaling? So it is a right. That makes sense? Good. How are we all doing over here? Did you all get right? Okay, so we are going to, I'm going to hand out some practice, or actually, Arlene will hand out practice. So in that blue, actually, I had these with me. So this is just plain worksheet, and then the word problems I'll be, it's just 2 pages. And then after break, I'll probably give you an extra time to finish this, but then I do want to try to introduce similarity if we have enough time, but I think we will. Actually, you can use those notes on the test, you just can't use your worksheet. Okay, for the test, I am not evil. I know that some of you, English is your second language, so sometimes word problems are very difficult. Is that a true assessment? Yes? No? Maybe? Okay. The word problems that Eileen's going to be passing out, I'm going to pick problems from that worksheet directly, right, for the test. So you don't know which one I'm going to pick, but it's going to be one of those. And then that way you can review that vocabulary, and it'll be easier for you for knowing what the word problem says. Is that fair?
Yes.
Okay. It should be right. It should be right. Oh, because you put a 2. That's a 9. Oh, get work. Okay. Something hard to know.